In this video, I'm going to go through some highlights of what you're going to need to know for your Algebra 2 Unit 2A test coming up soon. Remember, as you go through this review, the answers are all on the back, so please do not just guess that you're doing right. Make sure you double check every single time that you're doing it correctly. Okay, for this first chart, what it's asking you to do is if I give you a number on the left, first off, I want you to simplify whatever was over there on the left, but then what I also want you to do is convert it into exponential form and write it to me just as an exponent. And if I give you a number on the right, you're going to go backwards. So you're going to put it into radical form and you're going to simplify it. So you're going to fill in the opposite box in each one. I'll go through and do a couple just to show you what you should be doing. For this first one, to rewrite it in exponential form first off, remember that your index, this 3 out here, becomes the denominator in your exponent, and the actual exponent that was there stays. So this is going to be 3 to the 7 over 3, and that's all I want to see if you write it in exponent form. With this one, we can simplify the problem, so I am going to do that as well. You are welcome to do 3 to the 7th and then start dividing in your perfect cubes, but something that is probably easier is to think of that 3 as a variable and think about how many 3's you can take out of your problem. So we're going to go ahead. I have 7 3's, 5, 6, 7. Since it is a cube root, I need them in groups of 3 to take them out. So that means I can take out 2 3's. And you would have 1 left inside, so your answer here should be 9 cubed root of 3. If we look at, say, this third one down, where I give it to an exponential form, you don't have to do anything on this side. If I give it to you as an exponent, just leave it. But on the right side, we're going to put it into radical form, and then we're going to simplify it. So there's a couple things that will happen here. First off, because this is a negative exponent, it means I'm going to have a 1 over this 25 to the 2/3. And then I'm going to rewrite this as an exponent. So 1 over the cube root of 25 squared. Now if we try to simplify this one, I only have 2 25's in there, so I can't take any out. So what I would suggest is go ahead and multiply that out. So 25 squared should be 625. And then you're going to simplify your cube root. So just a quick refresher on that. Since this is a cube root, you need to divide your perfect cubes into it. So that means I'm going to do 1 cubed is 1, 2 cubed is 8, and keep going until I find, this is 27, 4 cubed is 64, 5 cubed is 125. You need to keep going until you find a perfect cube that divides into the number under your radical. 125 does just that, so I can rewrite this as 125 times 5. And the cube root of 125, if you use your list over here, is 5. So what I have is 5 times the cube root of 5 in the denominator of my fraction. Now this is something we could rationalize, but in Algebra 2 we didn't, so you do not have to worry about this. This is where you would leave your answer for now. Okay, so that's what you'll do for this entire chart, is go through and write it in the other form and then simplify your radical if it's possible. Looking through these next ones, I started to give you your operations that you're going to do. 2, 3, and 4 are all basically the same problem, but it's using different power lists based for each of the different problems. So I'm going to pick one of them, but they all work pretty much the same way. So if I do number 2, because it is a square root, since there's nothing written for your index, since this right here is blank, you're dividing your perfect squares into 750. So you have to know your perfect squares or be able to create this list. Okay, if we do this, 25 is the biggest perfect square that goes into 750, and it's 25 times 30. Make sure you put that back in a radical so that it reminds you to do this operation. So since this is a square root, I'm going to do the square root of 25 is just 5. And that is going to end up multiplying by that -4 that was in front of my problem. I'm going to leave some space because we got to talk about variables. But then the 30 comes inside, and it's always a good idea to double check your 30 and make sure no perfect squares still divide into 30. None of my other perfect squares do, so that means I did do the right thing and pick the right number to go into it. Looking at your variables, you have 3 m's, which means I can take out 1, but 1 will be left inside. And if I have 6 n's, I can make 3 groups of 2. So I will have an n cubed outside and none left inside. So my final answer is -20 mn cubed times the square root of 30m. 3 and 4 again are the same, but make sure on number 3 you're dividing in your perfect fourths. So you're going to do x to the 4th and make that list. And then on number 4 you're going to do x cubed and make that list and divide those numbers in. When you are adding and subtracting, like on 5 and 6, you want to make sure that you have like radicals, and that's when you can add them together. So your first step on both 5 and 6 is to simplify, just like we did on the previous problem, and then try to add them together if they have matching radicals. What I mean by matching radicals is that the radicand, whatever's under the radical after you simplify, needs to match. So I'm going to make up different numbers. This has nothing to do with either of these. But say you had 3 root 6 plus 4 root 2 plus 6 root 2. You would not be able to add the 3 root 6. You would only add the 4 root 2 and the 6 root 2. So my answer for this would be 3 root 6 plus 10 root 2. Okay, so make sure you're thinking about like terms. That's the only difference between 5 and 6 in these first 3 when you simplify. So you're going to simplify first, do exactly what we did here, and then if they have matching radicals, you add the coefficients in front of your radicals. That's how I got this 10. When you are multiplying, which is 7 through 10, you can do either the multiplication first or the simplifying first. It does not matter. So like on number 7 right here, because my indexes match, that's an important thing to check, you can go ahead and just multiply everything together. So say -12 times 4 is -48. I have x to the 4th and x squared is x to the 6th. And y times y squared is y cubed. And then you can simplify. Or if you notice it can simplify right off the bat, you can do it at the beginning. With multiplication, I usually multiply first and then simplify, just so I only have to simplify one time, but that's completely up to you. So this one you would keep going and find the biggest perfect cube that goes into -48. As a side note, remember if you have a negative under an odd index, meaning this 3 being odd, negatives are okay. You're just going to pull out a negative with whatever perfect cube you divide out of your problem. On ones like 8, 9, and 10, you're going to have to distribute or FOIL. 9 is a tricky one, so be careful there. Make sure that you remember this 5 root 6 is one thing, the 2 root 3 is one thing, and the 3 root 6 is one thing. What that means for you in the problem, you're going to do root 3 times the whole of 2 root 3, and you're going to get 2 root 9. You're going to do root 3 times the whole of -3 root 6, and get -3 root 18. You're multiplying under the radicals together. And you're going to keep going. You're going to do 5 root 6 times 2 root 3 gives you 10 root 18. And 5 root 6 times -3 root 6 is -15 root 36. You want to simplify every radical you can. So like what I noticed, this square root of 9 is just a 3. There's no more root. Be careful with that. This -15 now times root 36 now becomes -15 times just a regular 6. Both these root 18s you can simplify because 9 goes into it. And I'll tell you this is going to be -9 root 2 plus 30 root 2. You square root those 9s, it pulls out a 3, and then I multiplied by the coefficient in front. And then you're going to be able to do this multiplication at the front and at the back and combine some like terms. Okay, and make sure on number 10, write it twice so that you can FOIL. Going on to the next section, 11 through 16 are all your division problems, and I kind of jumbled them up to make sure that you're paying attention and you know what's going on. For these, when you have a monomial in the denominator, meaning one term, so like number 11, number 13, number 14, you are trying to cancel out whatever's in your denominator. You can look to try to simplify first. I'll tell you none of these simplify right off the bat. But when I force my denominator to be a perfect square, what you're focusing on is getting this radical to be a perfect square. So like on 14, the way I would make that 2 be a perfect square is by multiplying it by itself. So I'm going to multiply by root 2 over root 2. With your monomials, you will always multiply by whatever that radical in the denominator is. Okay? Make sure to distribute and do your multiplication correctly, but it should simplify and give you no more radicals. On 12, I'll give you a hint. I would simplify it first, because this one is pretty straightforward if you do simplify first, but it can be kind of tricky if you don't. On 15 and 16, and technically number 12, you have binomials in your denominator, meaning you have two terms that are either added or subtracted together. On these ones are where we have to multiply by our conjugate. And what our conjugate was is you take your denominator, whatever it is, and you change the middle sign. So on this one, I would multiply by 3 root 5 minus the square root of 10 on top and bottom. Okay, on 16, you'll multiply by 5 plus 2 root 3. So it's one of those rules you're going to have to know for your test. And then you go through and do the algebra. You're going to FOIL all the way through number 15, very similar to the way we did number 9. Okay, but you'll have to do it to the top and bottom. Your radicals on the bottom should all cancel out. And again, remember, you have the answers on the back page. Okay, moving on to this next section. Problems 17 through 25 are all very similar to what we did on day 5 with your exponent rules. And so what I want you to remember is a few different things. First off, your exponent rules, when you are multiplying like bases, like on 17 or on 20 or 22 or on the top of 24, you are adding your exponents. So on 17, I'm going to do 1/3 plus 2/5. Okay, and same thing on the rest of them. You will add them together. When you are dividing, so like on 18 or on 23 or eventually on 24 and on 25, you are subtracting. So I'm going to have to subtract these exponents. To give you an additional hint on like number 18, I don't see all of my exponents on number 18 yet, so I need to rewrite them so I see an exponent on everything, which means I'm going to rewrite the bottom just like you would have done on number 1 as 7/4. So rewrite everything as an exponent on this problem if it's not done already. So that's another good hint for number 22, 24, and 23. Rewrite everything as an exponent. And then I'm going to do my subtraction, 7 minus 7/4. Okay. On 19 and 21 is where you are raising a power to a power, so you will multiply. So I will do 1/4 times 6/7. So make sure you are keeping those 3 different rules straight. Those will be super important on your test. Just to go through and finish one out for you so you know how to do it. Remember that when you are adding, you need a common denominator. So if I'm looking at number 17, my common denominator is going to be a 15 because I have a 3 and a 5. So I'm going to multiply the first fraction by 5 and the second one by 3. So this is 5/15 plus 6/15, which is 11/15. This 11/15 is my new exponent. And the questions on the test, much like the first problem you had to do, will ask you to write it in simplified radical form. So I have to rewrite this as the 15th root of p to the 11th. And you do need to consider, can I simplify this? Well, if I only have 11 p's and I need 15 to take them out, that's my final answer. Okay, please make sure you're reading the directions when you take the test. I don't want to have to take off points because you didn't do that final step of just rewriting it like it will ask you to do. So any of them that are adding or subtracting, again, make sure you get a common denominator and do the operation and then simplify when you're done. One like 19 where you multiply, remember you multiply just straight across. So this is going to be 1 times 6 is 6. Over 4 times 7 is 28. Do simplify your fraction, so a 2 goes into both of those. This is 3 over 14. So this is really 2 to the 3 over 14. And again, we're going to write this as the 14th root of 2 cubed. If you want to write that as an 8, I have no problem with that, but you do not have to. Either of those would be the same thing. You cannot simplify it, so we're done. (26) through 34 are just like the last day of notes, so 1.6, where we dealt with complex numbers. Make sure on 26 and 27 you're simplifying. Since there's a negative under the radical, you're going to have an I in your answer, but you will do 26 and 27 just like we did 2, 3, and 4 on the front page of this review. For the rest of these, you have to know how to do your operations with whatever it may be. So for example, 28, you're just going to distribute this negative and then add your like terms together. Please do not FOIL that. That is not multiplication between your binomials. On 29 and 30 and 31, there is multiplication involved, and then you'll combine your like terms. What's super important, remember, if you ever have an I squared, you need to change it to a -1. If you ever have an I cubed, you're going to change it to a -I. And if you ever have an I to the 4th, make it be a 1, because I need my answers in the form A plus BI. So I cannot have an I bigger, to a power bigger than 1. 32, 33, and 34, you're going to address much like we did the rationalizing problems on the last page. Okay, on 32, we can't have an I in the denominator, so we need to force it to be a perfect square by multiplying top and bottom by I. 33 and 34, just like the conjugate ones we did on the last term, this is a binomial. Again, you're trying to get rid of that I, so you're going to do 2 minus 3I over 2 minus 3I. And again, you'll FOIL and combine your like terms, your I's should all cancel. 35, 36, 37 are basically like your problems from your day 1, but I'm making you apply it a little bit. What you have to remember, the area of a rectangle is base times height, and your perimeter, you should add all your sides. So that's the hint I'll give you there. Area of a triangle, remember, is 1/2 base times height. And then lastly, your square is going to have the same formulas as a rectangle, so base times height, and that your perimeter, you add all your sides. But please remember that in a square, all 4 sides are the same. So think about what that means for your problems. Okay, again, as I said before, make sure you're checking your answers with everything that's on the back, and if you run into a problem, feel free to come see me so I can help you out.